अस्सलाम वालेकुम डियर स्टूडेंट्स। तो आज हम डिस्कस करने जा रहे हैं मैक्सवेल इक्वेशंस और यू आर ऑलरेडी फैमिलियर विद द मैक्सवेल इक्वेशंस, राइट? But today we are going to discuss about combine these Maxwell equations, like we have these four Maxwell equations. Can we write them in some compact form? I mean to say, right? Like we have these two Maxwell equations. So first tells us that the total electric flux through the closed surface, that's equal to that 1 by epsilon times the total charge within that embedded within that volume, right? And similarly, we have this fourth Maxwell equation, that is that we can say that it is the modified form of this Ampere's law. So, according to which it tells us that this how this magnetic field is produced, how this field is produced due to the combined effect of the current density and that E. Right? So these are the two Maxwell equations. In my today's lecture, I told you that we can write that we know that we can write this F mu delta mu F mu equal to J0 G of mu, right? And this mu it is that it runs from that 0 to 3, 0, 1, 2, and 3. Right? It's because we are dealing with that we have that this four-dimensional space, so that's why it takes all the possible coordinates. That means first corresponds to a time component, and the rest three it corresponds to those space components, right? Let's come back to this first that Maxwell equation. It's also called that this Gauss's law in electrostatics, right? Gauss law of electrostatics, and it's also called that steady state equation because this equation is a time independent equation, and similarly this Maxwell this fourth equation this is time dependent because there is a time is dependent of time and this independent equation, right? So let us first, because we are familiar with this F-mu, so this is equal to minus E of x minus Ay and Ez. And we know that this electromagnetic field, as if you write it as covariant form, so covariant it comes out to be only the sign. There will be minus sign in this and this, and there will be plus, and rest will be same. So it tells us that this electric field is it changes its sign under the transformation, like it goes from E to minus E, right? When you transform it from, when you change this electric field from one frame to, when you move from one frame to another frame, right? So we can say that this electric field is a polar reactor, and similarly this magnetic field they remains invariant when you go from one frame to other frame, right? So we can say that this magnetic field is a this is called action vector, right? So coming back to our main topic, so that is how, can we combine these two equations? Can we write it in this form or not? Right? Starting from this is that Gauss's law of this electrostatics, we can write that this is delta dot E equal to, that's equal to rho by epsilon. Right? So because we write that, I'm talking about this the divergence here, right? But we have that it's a four-dimensional space. So if we write that the time coordinate here, because that is because this equation it is that this is time independent equation, right? So this is time independent equation. So this term that time component will be zero in that case, right? So we can write this as this nebula we can write as, so this can be written as that partial one comma partial two comma partial three, right? So this partial one corresponds to this x component, this corresponds to y, and this corresponds to z component. And similarly, this e I can write as, so this will be equal to e1 e2. Okay. So these are these three components of that electric field, right? So if I combine them, so you will get here that's partial one e1 So this is rho by epsilon naught. Okay, but we know that we know that our J0 equal to that's equal to 0, right? Our rho will be equal to J0 divided by C. Or you can write this as this is J0 divided by C epsilon. And that is partial 1 E1 plus, right? That's clear. Or you can write this as, because we know that we can write that C equal to, or you can write that C square, right? Because we can write this as C square because you know that you can rewrite this term as this will be equal to that Cj0 divided by C square epsilon naught, right? I multiplying by C and dividing by C, so this is Cj0 and this will be C square here and epsilon naught. Now instead of that 1 by C square, I can write mu naught epsilon naught, right? Okay, so let me write that. Okay, so because I need this, so that's why I need to put it as it is. So I can write now. So this will be equal to that partial 1 E1 plus partial 2 E2, right? Now instead of 1 by C square, because from here you can write that what's our 1 by C square? Because 1 by C square will be this one, right? Now use it in this equation because we have this Cj0 divided by, or you can write that epsilon naught here and mu naught. Okay, or you can write this as this will be equal to Cj0 and that is okay. So this is it. Okay, so let's write now. So this is our that we can write this as this will be partial 1. So what will be even here? Because uh, even is basically this one. Even or you can write this as, okay, let me write one more step. So this ex you can write this way and comma you can write plus partial 2 ey plus partial 3 ez. Okay, so this is it. Now, instead of this e of x, so e of x is because these are those components that is 0, 1, 2, 3, 0, 1, 2. So this is our which component e of x? That is our f10. So in that case, our mu equal to 1 and mu equal to 0. So this is 1 0. So 1 0 corresponds to our ex component, right? And similarly, ey is this component. Okay. So ey is our 2 0, right? And this Ez is that sort EC0, right? So we can instead of this electric field, because I need to write this in terms of that electromagnetic field tensor, right? This is what we have done today. So that was so using that four-dimensional current density, we have calculated that this dou mu f mu nu that's equal to some g nu, right? So we need to take it as inverse now, right? So can we, with the help of these Maxwell equations, so can we derive that covariant formula, or you can say that can we combine these Maxwell equations together, like what I told you, equation first and equation fourth, right? So let's try that. So this will be partial one. This will be f10. Okay, so these are three components, right? And that's equal to, okay, or you can, let me write this as, okay, so you can write this as, so this will be equal to, you can write this as, because you can introduce now the time component here, because if you write that partial 0 f00, so I'm adding this term, right? And as you say, that's partial 1 f10. Is it okay? Right. So this is what I have done here. I'm basically including, I'm introducing this term that's partial 0 f00, and rest is same. Okay. So because why I'm introducing, I'm adding this term because our f00 is this term, right? So f00 is this term, so this will be equal to 0.
वही वीडियो आता है कि भाई स्टूडेंट आ जाओ आ जाओ